Sri Gabin Katukaran, Director, Mechatronic Engineers Private Limited. Mechatronic Engineers is known for its engineering prowess, vast experience over 4 decades, and its ability to take on the most challenging jobs. Their machines are designed to meet the welding needs for a variety of applications, from general sheet metal industry to automobile, aerospace, railway, and many more. So let's all together welcome Sri Gabin Katukaran on the stage.
It's always a pleasure to be here at Rail Analysis, and I'd like to thank the team for giving me this opportunity to do that once again. I'm speaking about Mechatronic Engineers. As the introduction said, we've been building resistance welding machines for over 4 decades now, and we've been catering to a bunch of different industries, but we'll talk about our railway journey, which probably started in the late 80s, and it's continuing even today. So, a brief introduction to what we are, who we are, and what we do. We were established in 1980. We are headquartered in Mumbai. We have manufacturing facilities in Vapi in Gujarat, Vasai, which is just outside Mumbai, and in Bangalore. We have a sales and service presence in a number of other cities as well. So what we do is we are a complete provider of what is called resistance welding machines. These are basically a metal joining technology for sheet metals primarily, and a few other applications, one of which is what we are talking about today. We build a bunch of standard machines. We also build many special custom engineered machines for our customers. We also have a number of customized lines which are for specific products. These products may be from anywhere from packaging in automobiles, in fencing and construction, for the railways, a number of such industries. We do involve ourselves in turnkey projects to set up welding plants, and we also take up service and maintenance of these welding plants. The industries we cater to range from the automobile, railways, steel, power plant, nuclear fuel, aerospace, a bunch of them, because metal joining is something that is used everywhere. So we are involved in everything from making food packaging containers for everything from baby food to juices, all the way up to setting up or building nuclear fuel for nuclear power plants, so aircraft engines for the aerospace industry, and so on. Given that we cater to such a wide set of industries, we confidently proclaim that we build bigger, better, faster, and more welding machines than probably anybody else in the country. Over the years, we've built ourselves a reputation for handling difficult jobs, things that nobody else can do normally come our way, and we do that. We do a number of design and manufactured for the first time in India kind of jobs. We've built a reputation for supporting the Indian manufacturing industry, very often playing the role of import substitution, either in industries where it's expensive to bring in equipment from abroad, or it's difficult to bring in equipment from abroad for various reasons. We also put in a lot of effort to ensure that equipment is designed for our local conditions to suit, as some of the earlier speakers said, there's a dusty environment, dirty environment. The work culture is slightly different from the rest of the world, and we take these into account when we design and build our machines. Specifically for the railways, what we do is called rail flash butt welding plants. Now, whenever we are talking about upgrading the railway systems or building new railway lines, one of the key components is what is called continuous welded railway track, right? And this is a primary enabler for moving up the passenger comfort, moving up speeds, and we are the only company in India that manufactures these machines and plants. We are probably one of 4 or 5 in the world that do that. And as I said, we're very proud of the fact that we're the first ones in India to do it, so far the only ones to do it, and we've done it successfully as well. To give you a brief history of rail flash butt welding in India, by the late 80s, the railways had a number of plants spread across the country, from Meerut in the north to Arkonam in the south, Sabarmati in the west to Jharsuguda in the east, and a bunch of others. Now, all of these plants at that point in time were imported, either from Scotland or Sweden. The biggest problem that the railways faced was that one, the machines were not suited to our environment. There were frequent failures and breakdowns. And two, service and support was difficult. Either it was unavailable or it was expensive. In either case, it was very difficult at that point in time for the railways to manage these plants. And that's where we stepped in. We started by providing overhauling services for these plants to bring them back to a good working condition. We moved on to annual maintenance contracts to ensure that they kept running. And finally, offering spares to ensure that they run in good condition. In the early 90s, the Railway Board gave clearance for a new plant to be set up at Northeastern Railway in a small town called Gonda. Now, in the early 90s, this was a complete greenfield project, and Gonda was the kind of place where I think if you've seen the movie Sholay, that would have been a step up, right? In the sense that the kind of challenges that we faced in setting up the plant, when I say challenges we faced, I should say that I was not involved. I was in my early teens at the time, I suppose, or late teens, I think. And, but the company was there, and the number of challenges included things being stolen, looted, stuff being taken away at gunpoint, very little infrastructure being available. However, we did successfully install that plant. As I said, the first Indian plant completely of Indian design and manufacture. It was commissioned in 94, late 94 or early 95. Over the years, that plant built a reputation for being the best running plant of the Indian Railways. It set records which I don't think any of the plants were ever able to meet or even come close to. Some of the key criteria there, or the key features, was that it was designed for local conditions. For example, one of the systems that we did was the hydraulic system was split into multiple parts. The very sensitive servo systems were completely locked up. Nobody could mess with that. The other systems were relatively easy to maintain. So these are the kind of things which go into ensuring that the plant runs well in India. This plant had what was called an independent stripping machine, which I will show you in a later slide, has since been upgraded. At that point in time, we used analog welding controls, but in the early 90s, we had set up a fully digital data recording system. At that point, it was probably unheard of, but we had the data, and the data that we started collecting in the early 90s is still available now. The basic idea was that any track failure during the lifetime of the track should be traceable back to the plant from where it originated. Again, in the early 90s, we had a fully graphical representation of key parameters that could be watched by or that could be monitored by the senior management of the plant, and they could go back and check historical data as well. As I said earlier, this plant, which had by now run for, as of today has run for more than 30 years, consistently outperformed all the other plants. It set the record of making what is 20 joints per hour, which incidentally has gone on now into the latest RDSO specifications. Any new rail welding plant that is set up by the Indian Railways has to meet this requirement. And the reason for that was this plant that we had done. In fact, a lot of the RDSO people who have become the experts, not just the RDSO, in general, the Indian Railway personnel who have gone on to become experts in rail flash butt welding, cut their teeth on this plant. There is an RDSO manual on how to run rail flash butt welding plants, and the primary author of that was the guy who was in charge of this plant when we set it up. After the Gonda plant, there was a shift in policy, and the railway board shied away from setting up new plants. And the onus was pushed on to Bhilai Steel, who was responsible for supplying rail, to set up welding plants. We were instrumental in the first long rail project that was set up at Bhilai, and we completed that successfully. Sorry, that shouldn't have been there. In the last 10 to 12 years, we've seen the Railway Board take a new direction, and we're very happy for that. They've shifted focus to refurbishing and restarting and upgrading the existing plants. By now, I mean, I'm talking about around 2015 or so, there were just a few plants that were running. The others had more or less become defunct, and the operations were handed over to private contractors who would set up what are called mobile welding units and supply welded rail from them. Simultaneously at that time, along with this shift in policy, RDSO had been working on a new specification for setting up rail flash butt welding plants. We were happy to have participated in that. And as I said, the Gonda plant set the standards by which many of the standards that were incorporated into the specification. The first of this new generation of plants, which was set up by the Indian Railways, was set up by the South Central Railway in Secunderabad. We commissioned that in Jan of 2023, and I'm very happy to announce that just yesterday, it completed its 2-year warranty period, and we have got the warranty completion certificate of trouble-free running for 2 years, and now we move on to a maintenance contract that will run for 5 years. Right? Some of the upgrades in the design included, I told you that in the Gonda plant there was a separate stripping unit. That's been incorporated into the machine now. There is also an auto alignment system, which basically means that the operator of this plant pushes a button, the machine will detect the two rails that are being joined and will align them to the RDSO specs and then proceed with the welding. The welding control has shifted from analog to fully digital. We've also got an updated data recording system, which allows not only weld data to be collected, but also data from the ancillary machines to be collected and kept together, so that for the lifetime of that track, you can pull up any data that you want and look at it. So that's the completion certificate that we received yesterday. Just a bit of showing off on my part there. Sorry. Going forward, the plant that we set up in Gonda is now being upgraded. The contract was awarded sometime last year. We are in the process of executing that. We hope to finish supply by the end of March, and the plant should be up and running by June or so. This includes the welding machine, the straightening presses. We've also introduced a new piece of equipment, new for the Indian Railways, that is the rail end brushing machine. And we are also upgrading the rail handling systems to meet the new RDSO specification. Moving forward, we are hoping that the railway will set up more of these plants because, as we know, the demand for track is continuously increasing. We are happy to participate in that. And we are also happy that, what the panel was discussing earlier today about leveraging Indian capacities, local capacities over here, building indigenous technologies, reducing our dependence on international companies. Sorry to all the other presenters there, but we are happy to be part of that story, and we hope to continue to be part of that story for a long time. And we are happy to see that the Indian Railways has taken this particular path. Thank you.